Okay, last section we're going to deal with that will be on the test. First thing, we're on 4, section 6, okay, isosceles and equilateral triangles. Okay, we've kind of briefly touched on those in the past. We'll get a little more in depth into them today. Your two resources for this section, the chapter 4, section 6 PowerPoint, okay, good one to go over. Also, the chapter 4 notes, pages 20 to 22, okay? I put this information in there, and also the two theorems, a little more in depth, okay? They're easy theorems today. Okay, here we go. Isosceles triangles. Isosceles triangles are triangles that have two congruent sides and two congruent angles. If okay, we have two equal sides here. The sides that are the same length are called the legs. The other side is called the base. Okay? Now, in that isosceles triangle, the two angles that are opposite, okay, across from the equal sides are equal to each other. They are called the base angles. Okay. Here we go once again. Legs, base, base angles, that got messy. And this is called the vertex angle, okay? The vertex angle. Okay, now the vertex angle is important because it is the one that is not equal to the other two. And it's going to give you a lot of information. Okay, the two theorems that deal with isosceles triangles are real easy to remember. If you have a triangle with two equal sides, then the angles that are opposite them are equal to each other. Excuse me. Winds up, allergies go. Okay? The converse is also true and is another theorem. Excuse me. I apologize. If you have a triangle with two equal angles, then the sides opposite them are equal to each other. For example, if AB is equal to BC, then angle A is equal to angle C. Okay? The converse. If angle A is congruent to angle C, then BA is congruent to BC. Those two theorems. Now, equilateral triangles. Okay? As the name implies, equal, lateral, side, all of the sides are equal. Okay? They're all the same length. Nothing more to deal with there. Now, the other part of this is equilateral triangles are also equiangular, which means all three angles have the same measure. And that's really easy to figure out. If all three of them add up to 180, 180 divided by 3, okay? I hope I don't have to mention, but I'm going to anyway. Remember, sides are not equal to degree measures. Angles are. Sides are linear measures. They're lengths. Okay? Let's go do some examples. Yeah, the new stuff's pretty quick today. Okay, here we go. I've got 6 problems where I've asked to find the value of each variable. Okay? So here we go. First one's first. I have a triangle with 2 equal sides. Before I even look at anything, that tells me the following. Those 2 angles have to be equal. Okay? Closer to see that. So, if those 2 are equal to each other, that means this is also 2x, which now gives me 40 plus 2x plus 2x. Yes, you can jump ahead. Okay, so we get x equals 35. Down here, I have 2 angles that are equal. That tells me this side is equal to this side. There are going to be problems where they will give you too much information. They may give you all 3 sides. You need to remember these 2 angles tell me that the sides opposite them, these 2, are the ones that are equal. Those are the ones I deal with. Okay? So, okay? It's a simple math problem there. Okay, next one up in the middle. Now on this one I've got 2 equal sides again, but this is an important part. The vertex angle is 90 degrees. Remember on right triangles, you've already got a 90-degree angle, so the 2 remaining angles are acute, okay, and they add up to 90. Now, because these sides are equal, the legs are equal. The legs are also the legs of the right triangle. This is a special right triangle. It is a isosceles or an isosceles right triangle. That means each of these angles is 45 degrees. Okay? So here we go. Because we know this is equal, okay, I can say both will get you the same answer. Okay. Okay, down here, my vertex angle, and I know it's a vertex angle because these sides are equal, which means this angle equals this angle. This is 2x. This is 6x plus 6. That means this has to be 6x plus 6. This angle and this angle are equal. Yes, I have to put them all in there for this problem. Okay, I've got 2, 8, 14x. Okay, and that's how you work these out. One step at a time. The part we've got new today is what has to equal what. Up here, isosceles triangle. Those sides are equal. The vertex angle is 3x. That means each base angle is x. Okay? Okay, there we go. There's our setup. Okay. You're probably looking and going, wow, the math is really easy. And it is for the most part. Okay? There's very few times you get caught up on this. The important part is to find out what is equal to what. Okay? Here we go. Another isosceles right triangle. 5x equals 45. Or, if you're not there yet, remember these are equal. Okay, same answer either way. Okay, there we are there. Let's go over to the sideboard. We've got a couple more problems here. Types of ones to deal with. Now, this first problem gives me multiple triangles inside of here. And it asks me questions about these. So, if RV is congruent to RT, name two congruent angles. This and this are equal. We don't even worry about this right now. This angle V is opposite this. This angle T is opposite this. So angle V is congruent to angle T. Okay? Next. RS and SV are equal. Clearly not drawn to scale. If this is equal to this doesn't matter. Okay? So opposite SV is this angle. Opposite RS is this angle. Yes, we have to name them with the 3 letters this time. Okay? Important. Excuse me. Okay. Okay. So we've got this angle equal to that angle. Okay, so now we're saying angles are equal. Now if they give us angles, we're looking across to sides. Okay, so if SRT is congruent to STR, that means side ST, side SR. That's all. Okay. Last one here. STV is this angle. SVT is this angle. Doesn't exist for this problem. Okay, so if this angle is equal to this angle, follow across. That means ST, SV are our equal segments. Okay, there we go. Okay, getting a couple more colors here. Okay, now we're back to numbers. But we've got to look at a couple things before we get started. Okay? Okay. First things first. Look at what is given to you before we even start. LM, KM, KL are equal sides. That tells me right now that is an equilateral triangle. So each of these angles are 60 degrees. Okay, that'll be important. We know that KMH is 50 degrees. This is a part of our given information. I just couldn't write it inside the drawing. Okay, next thing. JM and JH are equal to each other. That's an isosceles triangle. We'll need that in a bit, because those sides being equal tell us that these angles are going to be equal. Okay? And our last one here, 1 and a 1, that means this is an isosceles triangle. And these angles have to be equal to each other. Okay? Important to know. Here's what we're going to do. Remember, when you get the M out in front, find the measure. So the measure of angle KML. We know that one. We already found it. Okay. Now we need HMG, this one. Well, if that's 60 degrees and that's 50 degrees, remember, those three have to add up to what? 180. Okay, so if I've got $60 plus 50 is 110. That's where I get 70 degrees there. Okay? Find the measure of GHM. Well, we just found that was 70 degrees. That means that is 70 degrees. 70 plus 70 is 140. Okay? Go a different color here. So the vertex angle of this isosceles triangle is 40 degrees. That's what we've got here. Okay, now, we put if in here. That says, okay, these aren't really going to come into play too much. So if angle HJM, if that right there, that vertex angle, if it's 145, okay, 180 minus 145 is 35. That means this angle plus this angle equals 35 degrees. So that means 35 degrees has to be divided into two equal parts to find out what each of these is. Okay, 35 and a half is 17 and a half. Okay, now, here's where it changes. Now it says if angle G is 67. Okay, if that is 67, okay, we're looking for angle GHM. We need to find this right here. So if this is 67, that is 67. 67 plus 67 is 134. 180 minus 134 that gives you 46 degrees. Okay? That's pretty much what your assignment's going to be. Okay? Okay. Good luck. Enjoy. Toodles.